So your 240 test is essentially going to be a similar test as what you had for the 220, 230. So your third semester test is very similar. Um, there are you're going to have a set of just basic unit conversions. So this is just your packet. You should have received this packet, and just because it was most consistent, and then I added some things to it as needed and really just focused on the uh on the questions that you'll be asked and to review. So some of the things that they're going to ask you to do this semester, they're going to have you do a little bit more of the conversion type questions, like how this is 250 micrograms, and then they're 0.25 milligrams per tablet. So you might have to convert micrograms to milligrams. There's also less images on the 240 test than what you've seen on the previous semesters. This is kind of a newish kind of question, so I think this is where I'll start, and then I'll ask you to practice this. And if you've already gone through these, or if you have specific questions that you want to look at, just drop it in the chat or raise your hand, and we'll address that from there. But I'll just go ahead and I'll start with this one, just because I know this is a newer one that sometimes gives students difficulty, but I'll make sure it doesn't bother you guys too much. So this is the dopamine infusion question, where they're going to give you some variables like 5 micrograms per kilogram per minute. They're going to give you a patient weight. If that patient's weight is in pounds, you need to convert to kilograms, but you can see it's already in kilograms. And then we have our available dopamine at 400 milligrams per 250 ml. And we just want to know what we want to set the infusion rate to, where the next question is, well, if I'm doing an infusion rate and I see minutes, am I looking for drops per minute, or am I converting this to milliliters per hour? If there is no drop factor, then you are going to be looking for ml per hour. Okay. So there's no drop factor here. So we are going to be doing ml per hour. So this is going to take a couple of steps to kind of work through this. So let's get started. I'm going to start off with the patient's weight, 70 kilograms. I'm going to multiply by the current infusion, which is the 5 micrograms, and that's kilogram per minute. And what that's going to do is we're going to eliminate kilograms, and we're going to be in micrograms per minute. So that is it's not a volume, but it's a weight per time. So it's still a rate. Now, a couple things. When we have micrograms and we have milligrams, we have to convert these things, because we cannot make the same we can't account for micrograms and milligrams without converting them in some way, shape, or form. So we can either convert micrograms to milligrams, or we can convert milligrams to micrograms. It's really up to you what you decide to do. To make this simple, I'm actually going to convert this, just because all I have to do is move the decimal point over 3 places. And I'm going to say it's 0.4 micrograms per 250 ml. So it's just reminding me that that's what this is. Like, that's that conversion. That way I don't have to worry about converting micrograms and then converting it to minutes and all that kind of stuff, or making any additional conversions at this point. And then obviously if you do it a different way, as long as you get the same answer, we're all good. Then I'm going to multiply, because I don't want minutes, I want hours. So I'm going to just go ahead and account for that right now, just so we're all set up. So at this point, I'm in micrograms per hour, but I want milliliters per hour. And since I converted my available to the micrograms, I can get rid of the micrograms, 0.4, and multiply by my milliliters, 250, and then I should be able to get my final answer. Now, some of these questions I think have the key is wrong, so I don't know if it's been corrected. So I'm going to take 70 times 5 times 60 times 250. I'm going to get 5,250,000. I'm going to divide by 0.4. Oh, hold on a second. I did something way wrong. What did I do wrong here? Oh, that wouldn't be 400. That wouldn't be 0.4 micrograms. That would be 400. That would be 400,000 micrograms. So I made a snafu. I apologize. Let me backtrack a little bit. I'm going to erase and we're going to come back to this. So anyways, so if you get some ridiculous 13,125,000 milliliters per hour, you know you did something really wrong. So that's definitely what I did. So I'm going to ignore what I wrote there. I'm going to come back and we're going to take a step back and we're going to just go ahead and convert micrograms to milligrams. And then that will just leave that at 400. So I was trying to avoid that step, but I did this wrong. So and I'm trying not to have giant numbers, so I'm not going to do what I said I was going to do before. So I'm going to convert micrograms to milligrams. This is 1,000 micrograms, 1 milligram. Then, now that I have gotten rid of micrograms, now I can multiply by my available of 400 milligrams, 250 ml. Milligrams are gone. So this is a long conversion factor. I'm mainly doing this because I don't want to chop it up. I'd rather just kind of show you all the steps right there and then just go from there. So I'm going to take 70 times 5 times 60 times 250, and then that's where I get my 5,250,000, whatever that happens to be, milliliters. And then I'm going to divide by 1,000. And then I'm going to divide by 400. Now I'm going to get an answer of 13.125, which is what I believe they have listed in the key, but we want to round that number to 13.1 milliliters per hour. So I apologize for the little snafu there, but at least you can kind of see that where mistakes get made. If I want what I needed to do, if I was going to do what I was trying to do, is I would have to make this 400,000 micrograms per 250 ml. That would be the correct conversion, but I know that nobody wants to do that or see that monstrosity of a number. Unless that makes it easier for you, then you can do that. But that's what I should have done. I did it. Um you can practice this one. It's the same kind of step up. Oh, go ahead, Rachel.
Okay, so we could still do it the way you were just doing it with the 400,000, or we could also convert it to 0.005 to turn it into milligrams, correct?
Yes. Yes, that would
Okay.
be, yeah.
Okay. I started getting confused, so I'm like, that makes sense to me how you were doing it at first. So I just wanted to confirm that.
Yes, you are correct. Yes, I
Oh,
apologize. I made a mistake, and so you're like, "Oh, this is easy," and then and then I realized that my numbers were wrong. So, yeah, if you
this was
take
one, sorry, this was one question that I had circled because I wasn't sure what they were asking for, so I'm glad. So if there's anything that's like an infusion, and if they don't ask for something specific, just know that it's milliliters to hour.
correct, yeah. The other trick is like they will give you the drop factor if they're looking for the drop rate. Does that make sense?
Yes. So that would be like drops per minute or something,
Drops per milliliter.
or
So
per
like,
milliliter.
yeah, so like hold on, let me go down to one and I'll show you what that looks like unless they're not here. Just give me 1 second. Yeah, right here. So number 19, it says you have 500 milliliters. It's infusing at 120 milliliters per hour. The drop factor is 15 drops per milliliter. So they have to give you that in order to get to this, the drops per minute.
Okay.
Yeah, good question. So if you want, you can practice this, the question or the second part of question 11 using the different numbers here if you want to practice that, and then you can type out your answer. If you want me just to move along, I can just move along too. So one second here. All right. So that was kind of like, I think the main thing with that one over the last couple years that last couple semesters that question's been asked is, I think I said the key is it's miskeyed. I think it's 13.125 um, milliliters per hour. Like they didn't, and that may be my fault. Like I may have been the original creator of this question, but you should be rounding it to the nearest tenth following your rounding rules, unless they tell you specifically not to, but I'm pretty sure they want you to. Yeah, and this is just like another type of question, right? So if you
Real quick,
oh, go ahead.
can we, so I don't have that one written on my paper and I'm trying to solve it real quick,
Oh
just
yeah, go
because
ahead.
it's similar. If just give me like a couple more minutes.
Okay, yeah, go ahead. I'll leave it right
Right.
there. Yeah,
Thanks.
so and you have
Same
access to
here.
all this too on the shared OneDrive folder. So this is just I pulled this off of the shared OneDrive folder. So you have access to this too as a blank. Right. So this question can take some time to kind of navigate. Um, but I'll highlight the important things as you're still working through this. I do have one answer already, so I'm gonna confirm that answer here.
Can I
Um,
say my answer real quick?
yeah, go ahead.
I don't know. I just scrambled with this, but I got 187.5.
Okay, so let's take a look. The other answer was 18.8. So I got to
Okay.
see what it is because I don't have it memorized the answer either. So I'm gonna work through it with you both. Um, so um, I'm gonna I'm gonna follow the long strategy again, just because that helps to like take out any of the additional things, even though like I could convert that 25 micrograms into milligrams and just make it the 0.025, I think is what that would be, which isn't too bad. So you can do that, but I'm just going to leave the numbers just because I don't get myself all scrambled like I did before. And I know that a lot of these questions, students that are averse to the doing the what's it called? Uh, Dimensional analysis. You hate these questions, especially when I start writing them out like this. But again, I do that just because it helps with organization, at least for me. So for this one, I'm going to again start with the patient's weight, 50 kilograms, multiply by the current infusion, which is the 25 micrograms, and then kilogram per minute. So what I've done is I've eliminated kilograms. Then this is where you can either convert minutes to hours first or convert micrograms to milligrams first. So I'll just be consistent with what I did in the previous question. So 60 minutes, 1 hour. So minutes are gone. Then I need to get rid of micrograms, convert that to milligrams. So 1 milligram is 1,000 micrograms. Now, all of this is just kind of like the workup step just to get to do something with the 500 milligrams, 125 ml. Okay. Then my last conversion is just that. I want ml on top and I want to get rid of milligrams. So milligrams are gone. 125 ml, 500 milligrams. And then we're left with milliliters per hour, which is what we're looking for. Now, plugging it into the calculator, right? Because there's a lot of numbers here. So I'm just going to walk through and talk like what I'm doing. So I'm going to take 50 times 25 times 60 times 125. So I just plug that all into my calculator. I just multiply everything that's on the top and I hit equals. It doesn't matter, but I get 9,375,000. Then I'm going to divide by whatever's in the bottom. So I'll divide by 1,000 first, hit equals. Now I'm down to 9,375. Now I'm going to divide by 500. And then I'm going to get 18.75. So my final answer is 18.8 milliliters per hour. Now, I think, did you say you got 187 something?
I did.
So my guess is that instead of 1,000, you did 100, or instead of 500 milligrams, you did 50. So
Okay.
double check all your numbers. Make sure they're the same as what I have.
Okay, let me do it on a calculator real quick.
Okay.
Okay, yeah, so I did my conversion first and I turned it to 0.025 milligrams. So I did 12.5 instead of 1.25, and that screwed all my math up.
Okay. Okay.
Okay.
There, at least you found it, right?
Yes, thank you.
You're welcome. Yeah, I know that believe it or not, there's a lot of benefit in finding out, where you made your mistake, because that helps you to double check your work as you're going through it the next time around, right? So, um, that's okay. That's what we're here for, is to try and make these mistakes now and not during the test.
Right. All right, perfect. And then can I ask why so we just rounded that. I understand that. So like on the basic questions in the beginning, there's no trailing zeros. So
Yeah,
like for number one, it would be 0.75, right?
correct. Yeah. So yeah, no trailing zeros, but you also don't round those numbers.
Okay. All right, perfect.
Yeah.
Thank you.
Yeah, and you don't want trailing zeros for anything. So like you would not want to write 18.80, or let's say it was a whole number like 20, you don't want to write 20.0 milliliters per hour. You want to you do not use trailing zeros.
Okay. I'm only saying that because like last semester, the one answer, like I repeated last semester, so it was 0.160 and the professor marked it wrong because I didn't have the leading zero. And then but I only missed one on the exam anyway, so I didn't like really fight it, but I just wanted to confirm that.
Yeah, you do want the leading zero. You don't want the lagging zero.
I'm sorry,
Just in
that's what
case
I
I
meant.
said that wrong. So like for this question here, um, the correct answer, this correct should be 0.75.
I'm sorry, I meant to say trailing. You were correct.
That's okay. We were both saying the same thing, and I kept repeating leading, but yes, yeah. So if you wrote 0.750, yeah, they're gonna mark it wrong, even though technically, like, you didn't do anything wrong, wrong. It's just, but that's part of how they're grading you on these things. So
I'm completely confused. Can you guys hear me?
yes.
Okay. I'm completely confused on what you guys were talking about.
So what she was saying is like if you and you probably just like let's say if I wrote this answer as 0.750,
Oh, okay.
this would be marked wrong because
Right.
we don't want that.
Want the trailing.
Yeah.
Okay. All
Yeah.
right. Never
That's
mind.
all. Also, if you just wrote 0.75,
Right.
this will
You need
also be
that.
marked wrong because you're missing the zero in front. Does that make sense?
Yep.
Okay. Yeah.
Yep. Okay.
It's one of
Sorry.
those where you walk into a conversation and like, wait, is this something I need to know? What is this? And you are already
Yeah.
probably doing it the way
Yeah.
that they asked you to do it. So
Yeah. Thank you. Sorry about that.
no, you're welcome. I'm glad you asked. So it helps everybody. So okay. All right. Just because I have already like kind of um added some extra questions. Um So anywhere like if you go and you look at the practice set, you'll see there's some extra questions here. Like so if it says 14 and then there's another question, that's usually one that historically has been asked over and over again. And the reason for this one is because this one actually has a couple of like extra information um, that it's worth going through and looking at. So, like for number 14, it tells you you have a patient with congestive heart failure. They're being put on furosemide 200 milligrams IV daily. The available dose is 100 milligram IV. And then it says the label reads 30 milligrams per milliliter. And the question is, how many milliliters of the drug will you give? So what's confusing is there's two strengths listed here and there's no label, so you can't really look at the label, but you need to know what you need to use. And so what's helpful is that helpful little thing that you've been given over the years, the order over the available kind of helps you to keep in mind what you're looking for. So my order is the 200 milligrams. My available is a 100 milligram IV. That is correct. But how I get my dosage is what we need to pay attention to, that 30 milligrams per milliliter. Okay. So when I'm calculating this, I'm going to take my 200 milligrams times my available, which is the 30 milligrams per milliliter. It would be a mistake to divide by 100. So technically, this is what a reconstitution type question would look like. So this is a reconstitution question um, where you have to look at the label to find out the strength. 100 milligrams is the total in the bottle, and then 30 milligrams per milliliter is the what it's how it's being delivered. So my guess is that it's a 3 milliliter bottle. I'm assuming of 100 milligram IV. So you just do that calculation and then you'd get how many milliliters to administer. So I brought
Okay.
that up because either the key is wrong or we just needed some extra practice. Go ahead, Rachel.
Sorry, to raise my hand, I'm old. I'm trying
That's
to
you're
get there.
fine, please.
So the next one underneath is a practice one that's similar to that one, correct?
Yes.
Can we do that real quick? Only because I had number 14 circled as well.
Okay. Yeah, go ahead. Go
Are
ahead and
you
work
okay with
through.
that, Danielle?
Yeah, that's fine.
Yeah, go ahead and work through it and let me know what answer you get. All right, so following the same kind of criteria, right? We're going to, the order is the 150, and and then my label is the 60 milligrams per milliliter. So if you're doing order over available, you'd write it like this: 150 over the 60 times your quantity, which is just 1 anyway, so that doesn't change anything. Okay. So 150 divided by 60, I am going to get the 2.5 milliliters.
So while we're on this, I want to ask another question, and it's just so I don't get confused on something else. So, for instance, we're always looking at the order, not the available, correct? Like the order is the most important.
Well, no, you want to look at everything.
Right.
So what you want to decipher though from the text is, so what they're telling you is, like, do you know how, like, you have like a label, and let's say it's like Tylenol, and it's a 100 count, 100 tablets, but they're like 250 milligrams per tablet. That's what this is saying. They're saying that the whole, actually, you know what? There might be a picture of this. Sometimes there's a picture of this. Maybe not.
All I know is I overcomplicated the heck out of that question when I did it on my own.
You're not the only one. So what it is that there's extra information. It's good to know that this is a 100 milligram IV, but that doesn't tell you how to calculate the milliliters. That's why
Okay.
you need to look for what is the uh strength of the concentration, which is the 60 milligrams per milliliter.
Okay.
Yeah.
Thank you.
You're welcome. All right. The other commonly asked question, let's see here. It's usually these the heparin questions. So like they gave you like a starting point with this, and then what I did is I rewrote the heparin questions like this. So that way they're you could see the order and available. You don't have to see the monstrosity of the whole thing. Like you don't have to see like, oh my gosh, there's like all this information. I just condensed it down, because the only thing that really changes for these is what is the patient's weight. So I gave you a bunch of additional question, or two additional questions on the heparin protocol, just reminding you, like, I highlighted what's important in the heparin protocol, and then you ignore these things. Like, you don't need to worry about CBC or Gaiac stool or the neurochecks, how many ever hours. That's not what they're asking you in this question. They're just asking you to calculate a bolus and to calculate an infusion rate. Would you like to go through the heparin protocol?
Yeah, we could probably do that. Is this exactly the same as like the 130 or not 130, 230, 220 heparin protocol?
Yeah, the heparin protocol is what it is. So it hasn't changed between the
Okay.
semesters. So
Okay.
it's the same thing. Yeah, it's, and they just, so if you go back to like the 230 review,
Yeah.
and you can even look at, like, because I think I added like 5 or 6 additional practice problems for them, so you can see that there's multiple questions available.
I would
Okay.
like to go through it just as a
Yeah.
refresher.
Okay. Do you want me to go through like the big one here, or like the condensed ones?
Probably
Uh,
the big one, if
Okay.
that's
yeah,
okay.
Yep.
Because that one's more confusing looking.
Yeah.
right.
And unfortunately, I think that's what you're going. So like, I think that at like Boyce, campus. I think theirs
Yeah.
looks more like this, where
Yeah, it does.
it's just
Yeah, because
simplified.
ours. Yeah.
It's more like the other one.
Yeah,
Mhm.
Allegheny looks more like this. And so
Yep.
again, I take full responsibility because I'm the one who they said give us a heparin protocol question, and I put this together without thinking that maybe I should condense it down, because I didn't know what exactly they wanted. So you get to see the whole thing. So the whole purpose of this, like if you do a Google search for heparin protocol, or you look in any textbook for heparin protocol, they list the steps of the protocol 1 through 15, and they're all listed there, and then you're just supposed to use that protocol information to answer the questions. The questions you're going to get asked are you're going to get asked two questions, and the both questions will count as one question number. So like let's say it's number 25. It's just one overall question, but there's two parts to it. Calculate the bolus and calculate the infusion rate. Okay. Then for extra practice, I added in these additional things that you can do some additional practice with, and I'll go through it. But you don't have, you won't, you're not likely to get four questions. You're going to get bolus, initial infusion rate, or you're going to get the after a period of time, what's the new bolus, what's the new infusion rate. So, what we're going to do is we have to first just remind ourselves what this thing is telling us, and that's why I highlighted everything. Obviously, on your test, it won't be highlighted, but the important things we need to know are the patient's weight. We need to be able to, if it's not already in kilograms, we want to convert it to kilograms. We need to pay attention to what we have available. So we have 25,000 units and 250 milliliter half normal saline. We also have a bolus dose of 1,000 units per milliliter. So this first highlighted section here is your IV. Okay, so what the patient's the continuous infusion is coming from, and then the bolus is like a one-time injection into the IV to kind of get things started, or when we're recalibrating after the 6-hour check. Then this tells us what to do. It tells us to bolus with 80 units per kilogram, and then it tells us to start a drip at 18 units per kilogram per hour. And so those are the keys that we need to pay attention to when we're doing our infusion rate or our heparin protocol. So the first step is calculate the number of milliliters to administer for the bolus. So I'm just going to work through that. So step one is take the patient's weight. So we already have it calculated at 90 kilograms. And then multiply by the bolus. And the bolus is 80 units per kilogram. So at this point, if I were to hit equals and solve for this, I would be in my answer would be in units.
Wait,
What
wait.
I'm going to do, go ahead,
Where's the 80?
right here.
Oh, okay. Thanks. Sorry.
That's okay. Yeah, I've been doing this particular question for so long that like I have it memorized, so sometimes I forget to tell you where that information is, but it's listed here, and then even at the beginning of the question, it tells you to bolus the patient with 80 units, um, and then bolus with 80 units. It's repeated in here a couple times. All right, so 90 kilograms times the 80 units per kilogram. Then I'm going to multiply now by my conversion for my bolus, because if I leave it at where it is now, the answer will be in units, and the question isn't asking for units, it's asking for milliliters, because it says how many milliliters would I calculate for the bolus. So I need a way to convert units to milliliters. And here's where I think students make most of their mistakes is they know that this is the available up here. So they know that there's 25,000 units, 250 milliliter half normal saline, and I think some students even start to use that information to solve this, but we don't want to. We want to use the bolus dose information. because the bolus is what we're calculating. So the bolus is 1,000 units per milliliter. So that's what we want to utilize. So I'm just going to plug that in here, 1,000 units per milliliter. And so my answer, before I do any calculations, I can already see I'm in milliliters. So I'm going to do 90 times 80, divide by 1,000, and I'm going to get 7.2 milliliters. Unless I memorized that wrong, so I'm going to double check my work.
No, I got that too.
Okay, good.
Okay.
Yeah, so for so the only thing that really changes with the initial bolus is the patient's weight. So if the patient weighs 220 pounds, if the patient weighs 157 pounds, we could just change the patient's weight, convert it to kilograms, times 80, divide by 1,000, and that'll give you your bolus in milliliters if we're looking at the standard weight-based heparin protocol. Okay, like I said, if you do a Google search or you look in your textbook or even the textbook that they reference for the dosage calculations questions, the standard weight-based heparin protocol is these steps 1 through 15. So the only thing that really changes is the patient's weight. All right, so let's do the infusion. So the infusion, we're still going to take the same patient, 90 kilogram patient, but this time we're going to multiply by the infusion rate, which is we did the bolus, but now we're going to do our infusion rate, which is the 18 units per kilogram per hour. So I'm going to multiply by 18 units kilogram hour. What that does is it gets rid of kilograms. We're currently, if I just do my math at this point, it'll be in units per hour, but they're asking us to calculate milliliters per hour. So I want to do the same thing I did before, where I want to convert units to milliliters. So that's where we go back to our available, and then now we're going to use the 25,000 and the 250 ml because this is our IV, this is our infusion, okay? And the only time we're going to use the bolus is if it tells us to use the bolus. So 250 ml, 25,000 units. And then all we're going to do is multiply across the top and divide by the bottom. And we're going to get 16.2 ml per hour. So like I said, this is most likely what you're going to get on your test is like just calculate the initial bolus and calculate the initial infusion rate. And that would be one question. So there's two parts, one question, and then that's most likely what you're going to see and get on your test. The second section in that what I highlighted in green is just after they've been on this protocol for 6 hours, they reassess their APTT, and we find that the APTT is now 43 seconds. Okay. So we want to say, well, what do we do with that 43 seconds? We want to account for that 43 seconds by looking in here. So like if the APTT was 30 seconds, you would follow step 11 and just do what it says here. If it was, 60 seconds, then you would just follow here, which just says continue to current rate. So there'd be nothing to calculate. But since I chose number 12, or step 12, because it tells us to do two things. It tells us to bolus again, so rebolus, this time with 40 units per kilogram. and to increase the rate by 2 units per kilogram. So if they ask you to do these things, you just you just need to follow the instructions that they've given you. So I'm just going to pull this down just a little bit. So same patient, right? Same weight, 90 kilograms. But instead of the 80 units, now we're going to do 40 units per kilogram. Like I said, I'm just following what it says here. Since this is a new bolus, I'm going to use that same bolus dose information that was listed up here, the 1,000 units. So like I said, the trick to this is just knowing what pieces of information to use. So we want to use that 1,000 units per milliliter.
So they're just basically giving us another question to do.
Right. Like, well, I gave you another question to do. Like,
Okay.
I created this just for extra practice. So, like,
Okay.
when you actually do this, question, you're either going to get A, B, or you're going to get the 1, 2. You're not going to get all four of these things. You're just going to get most likely you're just going to get an initial infusion, an initial bolus, but I gave you some extras just in case they give it to you and you need it and it for extra practice. So just in case,
Thank you.
I try
Okay.
to give you a little overkill. And then when I do this, I get 3.6 milliliters as my initial bolus or my rebolus. Then for the new infusion rate, we have to do some additional calculations because it tells us to increase by 2 units per kilogram per hour. So what was our original? Our original was 18. And so now I need to increase that by 2. So instead of doing 90 kilograms times 18, I'm going to do 90 kilograms times 20 units per kilogram per hour. Like I said, I don't think you're going to have this question, but just in case, I wanted to make sure you saw it. And then we're going to use our available heparin, the 250, 20 or 250 ml, 25,000 units. So we're going to use that again in order to get rid of units and convert to milliliters because it's the same IV. They're already hooked up to this IV, so it's already working. And now we just plug that information in. So we're going to take 90 times 20 times 250 and then divide by 25,000. And when I do that, I get 18 milliliters per hour. When I was first learning how to do this particular type of question, I just added 2 to this. And the particular question I was working on, the answer actually came out. It was like the initial was 9, and then the AP the increase came out to 10. So I was like 9 plus 2 and I made it 11 and I was like why is this not working out? And I realized you can't just add 2 units per kilogram per hour to the milliliters per hour. You have to go back to the original 18. Now, the other reason I show you this is just in case, let's say they tell you the initial infusion rate is, or that the patient is currently on an infusion that's going at 22 units per kilogram per hour, but they want you now to decrease it by 2 units per kilogram per hour. You're going to have to recalculate it going from 22 down to 20. So it just gives you a reminder to double check that work and to know how to adjust those numbers if you get asked that question. I think you'll see questions like that more so on ATI than you will here, but on this particular test. But I figured I'd at least show it to you. And then these other two questions, they're just additional practice. So you can go through, and if you can answer these questions, then you'll be good to go. If you because we have to sign off, or I have to sign off for the next group. If you want to practice these and you want to email me your answers, I can confirm your answers. Or if you work through them and if you're back here on Thursday, I can confirm your answers with you and kind of go from there.
Okay, thank you.
Yeah, you're welcome. Yeah, and if you have any questions between now and then, or even accessing these practice questions, you can email me. I'm putting my email in the chat. And you can email me questions. If you can't come on Thursday, you like I said, email me and I'll try my best to address your questions via email. And if I don't hear from you, good luck on your test.
Thank you.
Thank you.
You're welcome.
Have a good day.
Thanks, you too. All right. If you guys are here for the Boyce 130 review, just give me a few minutes. I'll be back on in like 8 minutes and then we'll get started. If you have any questions, you can type them into the chat. Otherwise, we'll I'll get started here